All right, everybody, it is time for the last part of our lesson for this chapter. So hopefully by now you guys have gone and looked at the notes that are posted for the work-energy theorem. There's just a couple of things that I wanted to comment on. This lesson is actually really short and sweet. On a previous slide, we had talked about the fact that work is measured in joules and energy is measured in joules. And so if they're both measured in the same units, then they must be interchangeable. On a previous slide, I gave you the little symbol that work is equal to energy, and that was really just to get the concept across that they're both measured in joules, so they must be synonymous or interchangeable. However, in order for that statement to be true, we must add that symbol delta. So technically, work is equal to the change in energy. Remember, energy cannot be created nor destroyed. And so when we're talking about those closed systems, like a marble rolling up and down a hill and things like that, the energy is being transferred because of the gravitational pull from the earth on the object, and that's what's causing that potential energy to transition into our kinetic energy, and vice versa. However, when the earth is pulling on our object, the earth is actually performing work onto the object, which is causing the amount of potential energy to change. Well, if you looked at the notes from today's lesson, we weren't talking about things rolling up and down a hill. Instead, we were talking about objects that were being moved or manipulated, most likely because of some sort of applied force. So the example of the box that started off on the floor and then was lifted to some higher shelf later, some person had to physically apply a force upward in order to cause it to experience this displacement upward. And so remember, work is equal to force times displacement. So whoever came and applied that force to lift that object, they performed work. That work is what is then translated into the amount of potential energy that the object had up here. Because down here we had 0 height, so we had 0 joules of energy. So this work that was performed is what is transferred into the object to give it its potential energy at that location. The same can be said for the golfer who hit the ball. The ball has no kinetic energy because it's at rest. So the work that the club physically performed onto the ball is what is then translated into the kinetic energy of that ball. The most challenging thing about these types of questions is your ability to understand that, number one, we can't ignore the delta. There must be a change in energy. A lot of our questions have our objects starting with 0 joules or ending with 0 joules. So sometimes I think students often overlook the importance of the change in energy and just say energy is equal to work. But please be careful. You have to understand that it is always the change. We can have positive work done or negative work done. So if an object is moving, and so let's say that it has some amount of kinetic energy, and then that object comes to rest, then our kinetic energy would be 0. So in this case, work is equal to the change in energy. So my work is equal to, change is always final minus initial. So we would have 0 minus 5. So we have negative 5 joules of work performed on that object to bring it to a stop. Okay, and what that means, if we have to go back and remember that displacement is a vector, force is a vector, so we can have positive and negative forces. We can have positive and negative displacement. So if the force is being applied to work against the object's motion, it would be a negative force, which means the work done in order to bring the object to a stop would be negative work. Okay, so just be careful. These are minor little details. However, this is the difference between a correct answer and an incorrect answer. If we say that 5 joules of work are done in the positive sense, that does not have the same meaning as negative 5 joules of work being done. So make sure that you are careful to always account for the initial and the final. Make sure that you understand that the work being done is what translates into that change in energy. And then as far as the word problems go, it's not uncommon for us to give you the mass and the velocity that an object has, but then turn around and ask you for the amount of work done. And what I see most often in the classroom is that students immediately take this mass and velocity and they're like, oh, those are the parts for my kinetic energy equation, but then the formula is asking for work. And so once they realize that the question is asking for work, then they will automatically just say, oh, so I'm supposed to use force times distance, but you can see you don't have a force and you don't have a distance. So the trickiest part for this particular lesson is understanding that these are synonymous and that you can use either of these formulas to solve for work or either of these formulas to solve for the kinetic energy. At this point in the year, you should be in the habit of following the guess process. For those of you who have forgotten what that means or never developed the habit, I'm just going to review really quickly. This is the thought process. So G stands for identifying all of the variables you are given. So simply saying that I have a mass, which would be 5 kilograms, and I have a velocity, which would be 2 meters per second. That's identifying your givens. The next step in the guess process is identifying what your unknown variable is. And so here's where, if we're not going through the process, then it's really easy for us to get stuck on, oh, well, they're asking me to solve for work. The next step is to pick your equation, and your equation should be selected based off of what you are looking for and what you are given. In this case, the formula for what we're looking for does not match the formula that we are given. So what we need to do from here is either ask ourselves, is there a known value that is supposed to plug in here? Is there a formula, a different formula that I can use to solve this equation? So if we had more than one formula with a W for work, or is there a relationship that takes what I have and relates it to what they're asking me to solve for, okay? And so making sure that you're following through the steps and going through that thought process is going to be super important in this particular section of your practice work. And then the last 2 parts of the guess process is your substitution. So once you've correctly picked your formula, you're going to substitute. I did not spell that right. You're going to substitute your variables. And then always remember your final answer or your solution needs to have the correct rounded answer and units. All right, again, hopefully everything was short and sweet. I just kind of basically wanted to remind you of some details and make sure you guys understand that work is equal to the change in energy. So I hope everything is going well for y'all. And as always, if you have questions, send a message and ask your questions. Have a great day.